Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Lesson 4 of GMAT Math Basics. If you don't want or need help with math basics, then please check out some of our more advanced episodes that are either linked in the description of this piece of content or just earlier in the feed. For example, if you're just starting out with your GMAT studies, we've got a great episode called How to Start Your GMAT Studies in 2024 that's optimized for the new GMAT Focus Edition. If you need help with quant, we've got a quant for Focus Edition episode. If you need help with verbal, we've got a verbal for Focus Edition episode. If you need help with data insights, same thing. If you need help with GMAT Focus in general and you're just getting your mind wrapped around the new exam, we've got the ultimate guide for GMAT Focus for 2024. And we've also got a lot of other great content if you need work with your balance, if you need work with your other time commitments, almost anything that you could be struggling with in this GMAT journey. We've got you covered, and definitely reach out to us and let us know if anything's missing and if there's any places that we can be more helpful in your journey here. For now, let's continue with GMAT Math Basics, and let's talk about multiples, factors, and divisibility. Before we hop into our lesson, let's try a quick quiz to test your skills on this topic. Question 1. What is a multiple? Question 2. What is a factor? Question 3. How do you find a common denominator? Question 4. How do I use multiples and factors to reduce fractions? Question 5. What does it mean if a number is divisible by another number? Question 6. What is a remainder? Let's jump right in. First question. What is divisibility? Divisibility basically means all the cool and useful things that you can do with division. On the surface, it might seem like division is pretty simple and maybe isn't even worth expanding upon. But what I'm going to try to demonstrate to you here is how powerful different ways of dividing things up can be. Let's start by talking about multiples. What is a multiple? It sounds like a multiple is about multiplication, and from a certain perspective, it is. All multiples of 10 are 10, 20, 30, 40, 50, etc. And that's just 10 times 1, 10 times 2, 10 times 3, 10 times 4, and so on. So from that particular perspective, multiples are about multiplication. But when it comes to the GMAT, it's also very wise, in my opinion, to think about multiples in terms of division. For example, is 103 a multiple of 10? It's not, and there are a few different ways to figure that out. Let me just go long on this for a second. One way to figure it out is to think about all the multiples of 10. You just count them up in your head: 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, 103 doesn't fit in that sequence. Or you could use a shortcut and think about what all the multiples of 10 have in common. All the multiples of 10 are going to end in a 0, and 103 does not end in a 0. So that's another tactic you could use there. Or you could think about it in terms of division. And you could ask yourself, if I divide by this number by 10, do I get an integer result? If I divide any multiple of 10 by 10, I should get an integer because multiples of 10 are just 10 times every other integer. 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5. So this is a bit of a potential mindset shift, and it might seem insignificant, but I promise it will help. It's valuable on the exam partly because time is scarce, and it could take a long time to think about all the multiples of 10. I've intentionally chosen 10 as a straightforward example, but if you think about all the multiples of 7 or all the multiples of 19, that might be a little bit less intuitive. And that's what I'm trying to set you up for success with this whole series. Now, it still takes time to divide something by 10 or by 19, if we were going to use that example, but it's usually faster and more predictable. This is just what I've found, and that can be a little bit counterintuitive, but I've observed just an absurd number of humans go through this process of preparing for the GMAT. And this is a reliable data point. Now, there are shortcuts. I mentioned one, like knowing that all the multiples of 10 end in 0, and those shortcuts are awesome. I'm not going to take anything away from those, but that's more getting into like the strategy of the exam, which is really the next layer or next two layers on top of the layer that you and I are building together right now. So we will definitely get there in time, but I don't want to focus on that kind of thing for this Math Basics series. I just want to make sure that your fundamentals are rock solid or better. So coming back to this idea of using division to whether think to figure out if something is a multiple of something else. So if we think about, is 103 a multiple of 10, we could just divide by 10. Now again, that might seem like overkill with that particular example, but what if I asked you, is 103 a multiple of 19? Well, thinking about all the multiples of 19 is probably going to be a lot of work if you're like most people. Maybe not, but if you're like most people, it probably is. It certainly is for me. And also, I don't think, at least I'm not aware of any really clever shortcuts for divisibility by 19. Now, maybe there are some out there, but honestly, if we're getting into memorizing that kind of stuff, now we're memorizing these like super hardcore edge case type things, which could like corrupt some of the memorization of the things that we should really focus on that are the really high leverage things to memorize. And that's definitely a problem I see with folks studying for the GMAT. There's so much that you could know. Sometimes as a student, it's quite difficult to figure out what you should know. What are the highest leverage things that you can know? And that turns into a question about prioritization, which is really another word for efficiency. And that is my current role in your prep. So, what I'm trying to help you do here is figure out not just a way to figure out if 103 is a multiple of 19, but what is the most efficient way for you to do that, not just on the test, but in terms of your prep time as well. And I think you will get the maximum leverage out of thinking about this idea of multiples in terms of division more often than thinking about it in terms of multiplication. Now, there are times to think about it in terms of multiplication, and we'll get to long division down the line. But for most of you, just dividing 103 by 19 will probably be the most efficient way to figure that out. And I think that that's a little bit unexpected, that multiples end up largely being about division when it comes to the GMAT. For sure, math in general, it would be hard to make that argument, but of course, we're here to talk about GMAT math specifically, not just math in general. So a few more examples of multiples. Some multiples of 3 are 3 times 1, which is 3, 3 times 2, which is 6, 3 times 3, which is 9. Some multiples of 7 are 7, 7 times 1, or 7 times 2, which is 14, or 7 times 5, which is 35. So that's multiples. Let's define exactly what we mean by multiple. Multiples are only relevant to specific numbers, as in 100 is a multiple of 10. It doesn't mean much to just be a multiple. We have to be a multiple of something, or more accurately, a number needs to be a multiple of something, usually one specific number. So the best way to define a multiple, in my opinion, is a certain number multiplied by any integer. So we pick the number and then we multiply it by any integer in existence. That will be a multiple of that certain number that we picked. So again, a specific number multiplied by any integer will yield a multiple of that number. Again, a multiple by itself doesn't mean much. It's always a multiple of something. That's key. This is particularly important on the GMAT, but that'll become super, super clear later, so I'm not going to go any further with that. Typical GMAT style questions involving multiples would be something like, what's the sum of all the multiples of 7 between 100 and 300? Something like that. There's a lot of tactics to make a question like that simpler and easier to do under time pressure and without a calculator. We'll get into those later. Or questions like, is 39 a multiple of 7? That's more relevant to our math basics lesson right now. So that's multiples. That brings us to the subject of factors. What is a factor? A factor is a number that divides another number evenly. What that means is that the result of the division is an integer. If I divide a number by a factor of that number, I will get an integer result 100% of the time. For example, 10 is a factor of 20. What that means is if I divide 20 by 10, I get an integer result. In this case, 2. 10 divided by 20 divided by 10, is 2. Now you might notice that 20 is a multiple of 10. And that's because factors are very related to multiples. It's a bit of a mouthful to put into words. But if you listed out all the multiples of a number, let's say 10 again, 10, 20, 30, 40, 50, 10 is a factor of all of those numbers. So if we were to put it into words, a number is a factor of all its multiples. I'm going to say that again. A number is a factor of all its multiples. Think about that for a moment. Any given number is a factor of all of its multiples. Think about 7. Let's list out some multiples. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21, and so on. So what happens when I divide any of those numbers by 7? I will get an integer result. Hence, any number is a factor of all its multiples. That's factors. More to come built on that concept in a moment. Why do we care about multiples and factors? Well, number one, many GMAT questions are simply about multiples and factors. Again, we will get into plenty of examples of those down the line. But another reason to care about multiples and factors is that they make dealing with fractions much, much easier. So in our previous lesson, we were discussing fractions. Multiples and factors are really, really useful tools when you're dealing with fractions. Let me explain. There's 2 primary ways that multiples and factors help us with fractions. Number one, they help us find common denominators for adding and subtracting fractions. I promised we would talk about this in a previous lesson. Let's get into it. So let me ask you this. How do you find a common denominator? You find a common denominator by finding what's called a common multiple. In fact, let's return to our previous example that we used when we were talking about adding and subtracting fractions, and I'll show you how finding common multiples is really how you find common denominators. So, quick quiz recap. Do you remember how to add 1/2 and 1/3? You might recall that we used a little trick. We multiplied by 1 in a very creative way. Just to rehash, we multiplied 1/2 by 3 over 3 to turn it into 3 over 6. 3 over 6 and 1/2 have the same value. We then transformed 1/3 into 2 over 6, and we did that by multiplying 1 over 3 by 2 over 2. 2 over 2 is just 1, so it doesn't change the value of the expression, but it changes the way it looks, and that is what allows us to have common denominators, which makes it easier to operate on fractions. So then what we did, instead of trying to add 1/2 and 1/3, we instead just added 3 over 6 plus 2 over 6. And that makes life a lot easier for us because we do not have access to a calculator or artificial intelligence of any kind on the quant section as of today. And so we use good old fashioned human intelligence. And we get 5 over 6. So I promised that I would discuss how I knew that I wanted to multiply 1/2 by 3 over 3 and how I knew that I wanted to multiply 1 over 3 by 2 over 2. And here it is. I knew that because I was looking for a common multiple of the denominators. And a common multiple is exactly what it sounds like. It's a multiple that's common to 2 or more numbers. In this case, again, we just need a common multiple of both denominators, or all the denominators if we're adding or subtracting more than 2 fractions. Here we'll just stick with 2 fractions for simplicity's sake. So the first denominator is 2. That's on the bottom of 1/2. The second denominator is 3. That's on the bottom of 1/3. So what are some multiples of both 2 and 3? 6 was the first one that came to mind for me because that's just 2 times 3. And that's a great way to go when you're finding common multiples, is just multiply the two numbers together. Works every time. Now, it might not be the simplest or the easiest way in every situation, but it is a simple way to find common multiples. You might imagine, though, that we could have used 12, which is another common multiple of 2 and 3. We could have used 18. We could have used 24. And all we have to do is just shift which numbers we are multiplying by. So, for example, if we wanted to use the common denominator of 12, I would have multiplied 1/2 by 6 over 6. That would have turned it into 6 over 12, which has the same value as 1/2. Similar things we could do if we wanted to use 18 or 24 as common denominators. It's really any number that's a common multiple of both 2 and 3. So that's how you find common denominators. You just find common multiples. I wanted to pause on that and address it here after we had talked about division and divisibility and multiples, because I think it makes it easier to understand that concept. So hopefully you agree that that was an artful way to build those two concepts up. Now, quick aside, you might hear a lot of people talk about least common multiples, and those can be super, super helpful. But being real with you, it's honestly not that important when it comes to adding and subtracting fractions, because you can always reduce. And we'll talk about reducing fractions in just a moment. So I just don't want you to get too neurotic about finding like the least common multiple or the like quote unquote most efficient way, because sometimes things that seem efficient on the surface are actually inefficient because they cause you to overthink things or overstress or make mistakes that you wouldn't have made if you just used a more intuitive approach for you personally. And I've found that that can be a major sticking point in the GMAT industry, because there's a lot of different people with a lot of different philosophies. And unfortunately, I think, maybe it's just for better or for worse, a lot of those people are great test takers themselves. And that's why they got into this line of work in the first place. But that doesn't always make them the best guides for people who are not naturally great test takers. Okay. So I don't want to throw anybody under the bus here, but I just want you to be aware as a student of who you're taking your advice from. And you want to always ask yourself, is this a person who's just had success themselves? Or is this a person who's had tremendous success helping other people? And ideally, people like me in my situation, have they helped people like me in my situation multiple times? That's usually the best fit for someone who's going to be able to help you out and who's going to be the highest value information provider, because I think a lot of us are on information overload in general these days, and I think that's very true of the GMAT space. There's a lot of noise, there's a lot of options. I think there's a lot of overwhelm. I think I did a whole episode a few weeks back on how to deal with that overwhelm. In fact, yes, I remember it clearly. It was like a very present in my existence. I had talked to like several people that week who were mentioning that word, and that's just an easy filter that you can use. I'm not saying you can't learn anything from people who've gone before you or that you shouldn't listen to them at all. It's just if you have two conflicting pieces of advice, I recommend trusting the person who has the most aligned results with you personally. Maybe that's obvious, but I think it's helpful to be reminded here and there. And it's very, very easy to go down the rabbit hole with this math basic stuff. And that's exactly the opposite of our intention with this program. We don't want to overload you at the very beginning of this. We want to keep it simple, but make sure that we're not leaving out anything that's crucial down the line. We will get plenty complicated down the line. For now, we're keeping it simple. So that's how you find common denominators. And this is part of the reason we're talking about multiples and factors. It's very, very helpful. The second way that multiples and factors make dealing with fractions easier is that they can help you make fractions smaller and simpler. This is sometimes called reducing or simplifying or canceling. It all refers to the same thing, basically making fractions smaller and simpler. So, question for you. How do I use multiples and factors to reduce fractions? Understanding this topic allows us to be a lot faster when dealing with fractions, which is nice. It's great, actually, partly because of the time pressure of the exam, but also because we don't have a calculator. Would you rather deal with a simple small fraction or a large complicated fraction if you don't have a calculator? I know which side of the fence I'm on there. All right, so reducing fractions. Let's use an example. Imagine the fraction 4 divided by 8. It's not too tough to deal with that if we wanted to add, subtract, or multiply 4 divided by 8. But again, would you rather add and subtract and multiply a small, simple value on the exam without a calculator or a more complicated value? So simple and small is usually best. When we're dealing with fractions, we're going to look for that common factor. We're going to look for something called a common factor. It's very related to the common multiple that we were just talking about, but there's some important differences. So the common factor is a number that divides both the numerator and the denominator. Or if you want to think more generally, a common factor is a number that divides two or more numbers evenly. It's very related to a common multiple. In the case of fractions, though, we're specifically concerned with the numerator and the denominator. So another way of saying that is that we want to find a number that is a factor of the numerator and also a factor of the denominator. So let's return to 4 over 8. Is there a number that divides 4 that also divides 8? There's actually a couple. 2 works. 4 is a multiple of 2, and 8 is also a multiple of 2. So you could even think about common factors as common multiples. You can't really completely substitute them. They are very different in one regard, but they're very related in another regard. So 2 works. 2 divides 4 evenly. 2 divides 8 evenly. There's also another number that divides both 4 and 8, which is 4. So we have some options here. When it comes to reducing fractions, I'm going to return to this idea of not becoming overly neurotic about this. There's definitely a limit there, and there's no real right or wrong in my experience. Find the factors that help you personally reduce well. That's all that matters. It doesn't really matter what works well for somebody else. If it works well for you and you get the best results with it, nobody's going to argue with your results. So that is totally fine if you need a couple extra steps, which is what I'm going to walk you through here. Don't worry about that. Just block out the noise of people telling you that somehow the key to your great GMAT score and your MBA dreams is like reducing by the largest factor in fractions. It's the most absurd thing I've ever heard in my life. I'm not saying it's valueless. I'm just saying what's the relative value versus other stuff you could be focusing on doing well. That's something to consider. So let's say I decide to use 2 as the common factor in 4 over 8. So I like to write the top as 2 times 2 instead of 4. And there's a few reasons I like to do this. The first is it usually helps me avoid errors when I write more down. I've found that to be a common trend with most people. It's not 100% universal. If you get better results without it, then by all means, focus on your results. I'm never going to argue with your results. But if you're not seeing the results that you want and you find you're frequently making computational errors with fractions, then you want to add more steps to your scratch work. I know that might seem crazy and counterintuitive because there's so much time pressure. But if you need a way to help ease some of the time pressure, then I strongly recommend you check out the video on our website at thegmatstrategy.com. It's linked in the description below. And check out our video on how to reach your dream GMAT score in half the normal time. It'll teach you some really great insider information about the scoring algorithm and how you can help get yourself a little bit less time pressure and work a little bit less hard, but get a better result in the end. It's a pretty nice thing to be able to do. Reach out to us if you have questions about that. So back to the subject at hand. So I like to write the top as 2 times 2. So what I'm doing there is I'm acknowledging that 2 is a factor of 4. And I'm just writing it as 2 times 2, which is 2 factors of 4 multiplied together instead of 4. But 2 times 2 has the same value as 4. I like to write the bottom as 4 times 2, which is the same as 8. Then what I like to do when I have transformed 4 over 8 into 2 times 2 over 2 times 4 is I like to imagine splitting that fraction in half so that on the left I have 2 times 2, 2 over 2 in the case I just gave, and then 2 over 4 on the right. Or I might do it differently if I like having the 2 over 4 on the left-hand side. So it's totally personal preference. I think more often than not, actually, I do it the other way that I just mentioned. So I would do 2 over 2 on the top, and then I would do, 2 times 2 on the top, and then 2 times 4, 4 times 2, excuse me, on the bottom. And then on the left, I would have 2 over 4, and on the right, I would have 2 over 2. And I have those 2 fractions multiplied together. So that should remind you of what we were doing when we were finding common denominators, where we were just multiplying by 1 in a very creative way. So this, in a way, is kind of like the inverse of that, where we are dividing out 1 in a very creative way to make the fractions smaller and simpler. So when I have 2 over 4 on the left times 2 over 2 on the right, I can just transform 2 over 2 into 1. And anything times 1 is just itself. We were talking about that a couple lessons ago in operations. So what that means is we can effectively just ignore that piece of the fraction because it doesn't actually change the value of it. So that means 2 over 4 has the same value as 4 over 8. You could put both into a calculator if you want to prove that to yourself. So that's how you reduce fractions on a very basic level. Reducing fractions is a really valuable skill because it allows you to take complicated fractions and make them simpler, like I was talking about. So let's try another example. Let's say I have 4 over 8, and I notice instead that 4 is the common factor. Again, I would write out the top as 1 times 4, and I would write out the bottom as 2 times 4. Then I would split the fraction down the middle, and I would have 1 over 2 on the left times 4 over 4 on the right. Imagine multiplying 1 over 2 by 4 over 4. We would multiply the top by the top and the bottom by the bottom, which would yield 4 over 8. It would be the same value. It's exactly like finding a common denominator. Here we're just going the other way. So if we separate them and we have 1 over 2 on the left times 4 over 4 on the right, we can divide 4 by 4 to make 1, and multiplying by 1 does not change our value. So it's almost like you can just ignore that 4 over 4 part, and that's popularly called canceling out a common factor or simply canceling. Because the common factor of the numerator and denominator will always divide to become 1, we can simply cancel that common factor and deal with a smaller, simpler fraction instead. I think that's pretty cool. It's definitely pretty useful. Doesn't matter if you think it's cool. We're not here to debate how cool this stuff is, and we're certainly not here to debate how useful it is. It is very useful. Just run the numbers on some post MBA upside, and I think we will all agree as to the magnitude of the utility of this conversation. Okay, so just like finding a common denominator is super useful when we want to add or subtract fractions, finding common factors between numerators and denominators is extremely helpful regardless of the operations we're doing on fractions because it makes fractions easier to deal with. Now, there is another benefit to this, which is most of the time, the vast majority of the time, GMAT answer choices that our fractions will be in their reduced form. So this is also a very critical skill for being able to match correct answers to your math that you're doing on the exam. So quick recap, when you separate a common factor from the numerator and denominator of a fraction, then you ignore that common factor, you are canceling, also known as reducing, also known as simplifying that fraction. And the exam can use all three of those words. They all mean the same thing. That's reducing fractions. I want to round out our conversation by talking about divisibility in general, because that is the next natural progression here. Now that we have the concept of factors, multiples, reduction defined, we can more productively talk about what it means when a number is divisible by another number. So let me ask you, what does it mean when a number is divisible by another number? It means that when you perform the division, you get an integer result. Number A is divisible by number B if I can perform the division and get an integer result. So the concept of divisibility is really just a way of talking about whether numbers are multiples or factors of each other. I'm going to say that again. The concept of divisibility is really just a way of talking about whether numbers are multiples or factors of each other. So if a GMAT question asks you, is 100 divisible by 3? What it is really asking you is 100 a multiple of 3? Or if you prefer, you could think about it as, is 3 a factor of 100? They're actually all the same question. This is super, super important because the GMAT uses all three ways of describing the situation pretty consistently. So it's very worth memorizing that those three phrases are interchangeable. So just like it's worth memorizing that canceling, reducing, simplifying all mean the same thing, it's very worth memorizing that x is divisible by y is the same as x is a multiple of y, which is the same as y is a factor of x. We did get a pretty thorough treatment of multiples, factors, and divisibility in general. And all of that could really just be called divisibility. We talked about why we care about divisibility. We talked about how it's useful. So looking forward to next time, and hopefully so are you. In the meantime, and as always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which should be linked in the description of this content, and check out our video on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. Your work and your success here matters. It matters to you, it matters to me, and it matters to everybody you're going to interact with for the rest of your life. And you can definitely, definitely do this. It might not be easy, but it can be done. I'll talk to you all soon.